Alright, as initially promised, I'm going to show you how to find the data points that you need to put into the controller. Now, we start our analysis assuming that all the lights are off and we're under full daylight conditions, and daylight is beginning to come down in the space. So this would be afternoon. This would be as the daylight is decreasing, and we want our first stage of lights to turn on. We pick this point. We're going to pick the point here where the first stage of lighting turns on. It is arbitrary and it is up to us. So we have measured the contribution from each stage of switched lighting. Adding them together gives us our reference. Multiplying by 1.5 gives us our 150% point. We are going to arbitrarily pick, for our example, let's say about 10% above reference. So if that's 150% of reference and this is 10% of this is reference, then I guess 10% of reference is probably right about there. Okay? So this is our first point we're picking to put into the controller, and we're going to call it cut in 1, because that's what the manufacturer has named this stuff. Alright, so we got cut in 1. When cut in 1 occurs, we're going to have a set of controlled lighting snap on. We're going to say that that is A foot candles. This is the amount of lighting that is being contributed to this interior space when the first set of lights snaps on. Now, daylight is going to continue to decrease in this space. So we want to get down to around the same point as cut in 1 before cut in 2. And this is combined illumination we're showing you here. We want to figure out where cut in 2 is. Well, how much does the daylight contribution into the space have to decrease for cut in 2 to equal cut in 1? It's got to decrease by A. So cut in 2 is approximately equal to cut in 1, which we're actually programming these points into the thing, minus A. And that's what we program in here. Okay, let's try that again with a slightly better diagram, because I goofed the last one up, but the principles remain the same. We start with all 3 stages of lights, A, B, and C, channel 1, 2, 3, turned off. Daylight decreases into the space. Now, before we get to our reference illuminance, which is equal to the lighting from A and B and C foot candles, right? Because each of these things is the electric illuminance from channel 1 and 2 and 3 being turned on. And we've measured these. Before we started, we needed to measure A and B and C, the contribution of electric lighting to the combined illuminance in the space from each of the channels we're using, and adding those together gives us our reference illuminance, which is equal to A plus B plus C. And so we pick a point where we want the first stage of lighting to turn on. Now, it has to be above the reference illuminance. 10% above would not be a bad place to put it. You can put it down fairly close to reference, because as the day lighting comes down, it's going to come down slowly, and people will not notice that so much because their eyes will adapt and whatnot. So we're just going to say, for our example, we're going to pick 10% higher than our reference illuminance. We cannot go lower, so we will say 110% of reference. So we're just going to pick cut in 1 is approximately equal to 110% of reference, so 1.1 times our reference, which is equal to all the stages being turned on. Now, when we hit that point that we've selected, we're going to have a stage of lighting turning on. And we need to know what that is. Why? Because our next cut-in point is going to be when the daylight decreases like this, and we want it to be, that daylight decrease to be approximately equal to this stage of lights. So cut in 2 is approximately equal to cut in 1 minus A. Alright? Because we popped up A, and now we need to drop down by that amount, and cut in 2 is approximately equal to this cut in point minus its stage of lights. At which point, and we program this directly in, we get another stage of lights snapping on. Channel 2's lights, which gives us B foot candles. Now, daylight will continue to decrease in the space, bringing us to cut in point 3 for channel 3. And this is approximately equal to cut in 2 minus the foot candles from electric lighting of B. The third stage of lights cuts in. The rest of the decrease in the space is all daylight going down. When we run out of daylight, we're now going to hit a hard point, which is our reference illuminance, because after all we have A, B, and C turned on. So you pick this point, and then you use these simple calculations to determine this point and this point.